Good day, everyone. Welcome back to Learning to Understand Electrical Principles. Today we're going to cover Kirchoff's laws. So, Kirchhoff had main two laws when it came to electrical circuits. The first one was KVL, or his voltage law. KVL stands for Kirchhoff's voltage law. So, this states that the algebraic sum of voltages in a loop will always equal zero. So, there's a few words we need to understand there. So the first term is algebraic. This means that some of the terms can end up being a negative number. And then the next main thing to look at is it says a loop. So what is a loop? So if we draw a circuit that has a battery here, let's say two resistors like this, and a resistor like this, and maybe a resistor like this. Actually, let me. So if we were to take this and let's start numbering these. Let's number this. Let's make this. Oh, this is the positive side. So this is going to be V1. This will be V2. This will be V3. Actually, you know what? Let's put V3 and V. Don't know why does it keep doing that thing with the dotted lines. Who knows? So then this is going to be V4, V5, and V6. So that's now a voltage rise. So a loop is basically just a part of a circuit. So if I were to draw something like this arrow that goes around in a circle, well, this arrow is contained inside a loop. It's surrounded entirely by wire. These two could be their own loop. I could draw a loop inside here. I could draw a loop that contains both of these. As long as it's basically inside the circuit, it's technically can be a loop. So that can be a loop, that can be a loop, and this can be a loop. But for the sake of simplicity, we're just going to use this one for now. So this is the algebraic sum of all the voltages in this loop. What that means is we're going to take each of these voltages and add or subtract them along the path of the loop. So since this arrow is going around the inside, this resistor and this resistor are going to be ignored for now. So this is going to only include Vs, V2, V3, V4, and V5. And now we're going to look at the direction compared to this arrow. So this arrow is going up. And it goes around and then it goes down, and you can see it's going like this. It's going in a circle. So Vs is going in the same direction as that arrow. So we're going to keep that as positive. Now V2 is going in the opposite direction to that arrow, so we're going to minus that. V3 is going to be the same. No, it's in the opposite direction, sorry. So that's minus. And V4 is in the opposite, and so is V5. So this will then all equal to 0. So I don't fully understand why this works, but I believe it has to do with the geometry of circuits. Because if two of these branches are in parallel, if two of these voltages are in parallel, well, they'll be equal. So V1 is the same as V2 as per parallel circuits. And the total voltage that goes into a branch, or the total voltage that we start with in a section, such as like our V source, well, that voltage will be dropped to 0 at the end. So I think that's why, and no matter how you look at a circuit, it will always work out that the combination of all those voltages together will eventually equal to 0. Like if we were to take a look at the loop V1 and V2, you notice V2 follows the direction while V1 doesn't, which gives us 0. And therefore V2 is equal to V1, which is true for a parallel circuit. And you notice all these sorts of combinations, and I still don't fully understand why it works. But all I know is it does, and it holds true that any voltages, when added or subtracted along a loop, will always equal to 0. Now Kirchhoff's other law is the current law. We spoke about this in our parallel video. KCL, Kirchhoff's current law. This basically states that the amount of current going into the branch is the same as the current coming out. So the algebraic sum of current going in is equal to the sum of current going out. So if this is current A and this is current B, this is current C and current D, well then A plus B is going to equal to C plus D. And yeah, so the currents going into a node will always be the same. I think I said branch earlier, I meant node. So these currents going in will always be the same as the currents going out. And that's all you really need to know with Kirchhoff's laws. These are really foundational and will help you to actually understand circuits better. Thank you for your time.